Okay, so what we can also do is we have relations and functions where they can be represented by equations. So if we want to determine whether an equation represents a function, it's easiest to look at its graph. So for example 3, what we're going to do is we're going to graph each equation. We're going to determine the domain and range. And then we're also going to determine whether the function or the equation is a function as 1 to 1. Remember, we're not going to worry about onto, both, or neither. We also need to state whether it's discrete or continuous. Discrete points, continuous, smooth line. Smooth climb. They kind of rhyme. It makes sense, right? Smooth line, smooth climb, they rhyme. Holla. All right, let's graph this. We know this is going to be a line, so let's use our slope and our y-intercept. So the first number we want to plot is our y-intercept, which would be your number 2. So we're going to go up 2, start at your origin, go up 2, put a dot, and then from there you're going to use your slope, which is then -5 over 1, which means you're going to rise -5, go over positive 1. So if we go down 5 to the right 1, down 5 and to the right 1 again, then we can also go up 5 and to the left 1. Remember, negative slopes are lines that go down from left to right. So the next thing we have to do is we have to determine our domain and range. So your domain is your x values, your range is your y values. All lines, except for vertical lines or horizontal lines, have your domain and range as all real numbers. Another way to write all real numbers, I call it the double stick R. So you just put 2 lines and make it an R. Don't get confused with how it may look like your range, because I'm just abbreviating the range. So your range, your y values go all the way up, all the way down. That is a double stick R once again. All real numbers. Your graph never stops going down, never stops going up. So it passes your vertical line test, which means it's a function. It is also 1 to 1 because all of your x values and your y values pair up with each other. And since it's a smooth line, then this would be a continuous function. So on our next graph, notice we have a little squared here. That means it's probably not going to be a line. Disregard the onto, both, or neither once again. Thank goodness, you would dislike it a lot. In this case, what we're going to do is we're going to make a table of values. It's not a line, so you can't just use a y-intercept and your slope. So we go through here, and we're going to make a table of values, and we're going to say x and y, and I'm just going to use x values of -2, -1, 0, 1, and 2. When you get into graphing equation, parabolas is what we're going to have. You're going to see it's a little different sometimes, but we're going to go with these values. So I'm going to plug in a -2, and when you evaluate this, make sure you do your order of operations right. Square your -2 first, make it a +4. Don't multiply your -3 times -2 and then square it. So if you plug in -2, you're going to get -3. Let's plug in a -1. So -3 times -1 squared plus 9. That's going to give us a -3 times a +1 plus 9. Do your exponents, then your multiplication. So -3 plus 9 gives us a 6. Plug that in, and you get those values. So I'm not going to plug in the rest of these. You guys should know how to plug values into an equation. So if you plug a 0 in, you're going to get a 9. 1, you get a 6. 2, you get a -3. So if you plot all these points, like I said, some of you may notice this is going to be a parabola. So it should have a mirror image. So if we go 0, 9, 1, 6, 2, -3, these points should be mirrored on the left side of your y-axis. And they are, so we make our pretty little curve here. Opening down, it has a maximum, if you remember that. And what you're going to notice is this is, your domain is going to be all real numbers. It's always that way for a parabola. Now your range is a little bit tougher. You have to find the highest point it goes to would be 9, but its y is less than or equal to 9 since your graph is going down. Another way to write it is what we call set notation, and you say -infinity to 9 with a bracket around your 9. That's the highest it can go. So if you're including 9, you put a bracket. If you don't include 9, you put a parenthesis. This is a function because it passes your vertical line test. It is not 1 to 1, however, because you don't have each x value paired up with each y value. You have multiple y values. However, it is still